Hey guys, it's Mr. Riz, and this is the second part of section 1.4. We're talking about continuity, and actually we're going to focus on one-sided limits here. The one question people have trouble with is this. So, find the constant a such that the function is continuous on the entire real line. So we have a variable here, a, and we have a piecewise function. So if we look, f of x equals x cubed for any x value less than 2. So everything to the left of 2 is doing the whole x cubed route. Everything after 2 is a x squared. So it does a parabola after that. Now, we don't know what a is. It could be 2x squared, it could be 7x squared, it could be negative x squared. What we need to do is find an a where this exists. So well, let's look. Everything to the left of this is 2 is going to follow x cubed. So what we know is that f of 2, we need to look at that function. And f of 2 equals, well, 2 cubed, which equals 8. What we need to do is make sure that this point, the point 2, 8, also matches up or aligns with that, with the ax squared. So we need to make sure that f of 2, which equals 8, has to equal to ax squared. Well, we know since x is 2, we can replace it with a 2. So we know that 8 needs to be a times 2 squared, which 8 equals 4a. So in this case, a has to equal 2. And so if we were to graph this, we'd find out, okay, we would have regular x squared, which goes down, and then at 2, we followed 2x squared, which would just be a parabola, but it would definitely match up right there at the point 2, 8. Alright, now here's one that's a little bit differently. Alright, we're going to do the same thing. We're going to find the a that exists, but what we have here is that the whole function follows y equals 1/2. So just on a regular line, y equals 1/2. Except for at the point a. So wherever a is at, it doesn't exist there. It follows this function here. We need to find the a where that exists. Well, what we can do, we can treat this like a regular function. And so if we have f of x, which equals, okay, x squared minus a squared all over x minus a, what we could do, we know that there's a discontinuous point at a. We can remove that, though, by changing the x plus a over x minus a all over x minus a. Those cancel out. So this equation really is equivalent to x plus a. Well, we know that x plus a has to equal 1/2. What we also know is that this point is going to be at the location a 1/2. We don't know where a is, but we know it's going to be a 1/2. So f of a is got to equal a plus 1/2. So really we have a plus a equals 1/2, or 2a equals 1/2. So a needs to be 1/4 for it to work. Alright, if you guys have any other problems, make sure you ask. Hopefully you can do this and finish the first part of the homework quiz, which is the 1.4 quiz. Alright, good luck.